monitoring Galera cluster metrics. What to monitor? Well, there are a couple of things that we want to keep an eye on regarding Galera. So definitely we want to keep an eye on the cluster status. So we want to see the status of the nodes, the status of the cluster, the number of nodes in the cluster, and this kind of stuff. Flow control also is important because it gives us information about how the write-set replication looks like, and whether there are some problems with some nodes or not. And send and receive queue is kind of similar to the flow control. It also gives us insight into the write-set replication performance. So cluster status monitoring. Well, here we can see sample of the Galera node status tab from the cluster control. So you can see we have information about the node state. We can have information about node IP, the cluster status, cluster size, whether the node is taking part in write-set replication or not. So for example, from this particular screenshot, what we can derive? Well, we have 3 nodes, yes. 2 of them are up and cluster is in the primary status, which is good. What we can see that one of them is in a download async state, one is synced. We have a cluster size of 3, so it seems like the third node, which is down, is actually, it's taking part in the cluster because of the cluster size. And therefore, and given that the 202 node is in the donor state, it's very likely that this 201 node is right now receiving a full state transfer. And so it's not that bad state to be in terms of the whole cluster status, because sooner or later it should recover and the cluster should be back up. Flow control monitoring. So this gives us information about how large percent of the time the node stalls, because it was asked to do so through the flow control messages sent. And then the flow control messages sent. This is something pretty important because in Galera, the Galera is virtually synchronous cluster, and therefore it is supposed to be, all nodes are supposed to be up to date. So when a given node can't keep up with the write-set replication, then it will send the flow control messages to other nodes and basically ask them to wait for it a bit. So if we see a node with a significant amount of flow control messages sent, then maybe it may mean that this node is somewhat slower than the others for some reason. Maybe there's configuration, maybe it's hardware, maybe it's a workload on this particular node. But it's it just means that we are supposed to we should be looking into it in more details. As you can see, we can have this data graphed pretty nicely. In this particular case, is when you see at the third node at the bottom of the screen, the 0.113 node, you will see that this green, I hope you will see that this green flow control messages sent line is pretty high. It's almost at the same level at the flow control messages received. So it just it suggests to us that this node is sending the most of the flow control messages from whole the cluster, and therefore it's suspected. It may be for some reason it may be kind of slower than the others. So this is something that points us for further investigation regarding this particular node. Send and receive queue monitoring. So this bit in a cluster control, this column, it gives us the average size of the send and receive queue Those queues are used by a Galera node when, for some reason, it can't either send the write sets for in a needed time, in a needed manner, or to receive them and process them because of some reason. So if the send or receive queue is large, then it may mean that something is not entirely correct with this particular node. So the question is also what caused it then? Yes, but because it could be a node slowness. The node slowness can be something periodical. It can be a transient or it can be permanent state. It could be caused by some background operation, like, I don't know, a backup, or maybe a query that was a heavy query that utilized significant part of the resources, and as a result slow down the node. So even this simple counter may result in some insight into which node is a problematic one, and where should we start our investigation. And also we can graph this kind of data. Actually, this particular graph is not available by default in a cluster control, but as you can see, it's pretty easily to, it is possible to add some custom ones should you wish to do so. And again, if we look down at the 0.113 node, and compare with the first one, you will see that the receive queue is more spiky there, and it spikes, to larger values. So it is again one more reason to do some investigating, because this node indeed seems like it's somewhat slower than the rest of the cluster. And of course, there are some other Galera-related data which we may to take a look at. The certification distance, depth distance, gives us information on average how many write sets can be applied at the same time. Because Galera tries to parallelize the writes as much as possible, so it is pretty, and it can give us the information how many workers can efficiently be used by Galera to apply writes in the parallel way to speed up writes and to increase the write capacity of the cluster. There's also information about the segment ID. Galera uses segment ID to, it's by default. This is something that user defines, and we use those segments to make a distinction between the parts of the cluster which are located in separate, either geographically or for example, different availability zones in EC2. So we are using them to differentiate the parts of the cluster that are located in some other areas. It has some, Galera uses them to adapt the way how it replicates write sets. But in this particular case, this bit of information, we can use it, for example, at the first glance to see whether the problem, like slowness of the node or something, is related to a particular data center, for example, or is it cluster-wide issue, not dependent on the location of a given node. And then we have the last committed column, which basically gives us information about the sequence number of the write set that was last applied. This is something, it's useful because when the node is lagging, we will know how badly it's lagging. And it's also useful when the node was getting incremental state transfer and it's catching up on the replication, so we can monitor the progress using this particular column.